Boys and girls, we are starting with grade 11 trigonometry. First of all, I'm going to remind you about what you learned in grade 10, about the rotation of the arm. Right, in grade 10, we were only finding angles between 0 degrees and 90 degrees. If you can see all those questions that you revised, we're only finding angles in between 0 degrees and 90 degrees in the first quadrant. Right, so when the arm is rotated, we can rotate this arm to this quadrant, to the second quadrant. We can rotate the arm into the third quadrant and the fourth, so on and so on. Now, it was very easy for us to find this acute angle, let's call it theta, in grade 10 by using the function of an angle equal to a specific ratio. Remember, we use x, y, and r to find the acute angle. Now, when we rotate this arm in grade 10, starting from the positive x-axis all around to the second quadrant, we form an angle that is more than 90, but we were not actually finding that angle. We were only finding an acute angle in grade 10. Now, in grade 11, we're going to learn how to find the actual angle from the positive x-axis all around to the arm. Another thing that you learned in grade 10 is that when we were busy rotating the arm in the quadrants and finding the function of an angle in that specific quadrant, we realized that all functions in here are positive, and then the sign of an angle and its reciprocal are positive, and the tangent of an angle and its reciprocal are positive in there, and then the cos of an angle are positive in there from grade 10. All students take chances. This is just a joke. Please don't take it serious. Right. Now I'm introducing you to grade 11 work. Firstly, we start with reduction formulas. Right. This will help us to find angles when rotating the arm to other quadrants, measuring from positive x-axis. For example, let's say the arm is in the second quadrant. Remember, in grade 10, we were able to find those acute angles very easy by using the function of an angle equal to a ratio. Now, let's say we measure the angle from here to there. And then the size of this angle is 150 degrees. The actual angle from the positive x-axis to the arm. Now, if we construct to form a right angle triangle in this quadrant, from the end of the arm, we draw a vertical line and then perpendicular to the x-axis. A right angle triangle is formed. Okay, let's say this angle that is inside that triangle, let's call it theta. Now, what we call that angle, this angle is very, very important, is a reference angle. Right, I'm going to explain a reference angle thereafter. This is just an introduction to reduction formula. Now, a reduction formula talks about the situation where an angle is reduced. Reduction formula. An angle is reduced, but representing the very same function of the angle. For example, let's say we have the sine of 150 degrees. Now, this function, remember, all students take chances. All functions are positive in here, sine and its reciprocal positive in there, tangent and the cos. Right, now, the sine of 150 degrees is the same as. Now, when we refer to this triangle, what is the size of theta? The size of theta is 180 minus 150, because we are missing this 30 degrees to complete 150. Now we are using a right angled triangle. Now the sign of 150 is the same as a positive the sign of 30 degrees. And when you press this on your calculator, you're going to get the same answer. Right, for example, let's press a sine of 150 equal to positive half. Then it is the same as the sine of 30 degrees. It is half. Right, now what we can say is that we reduced 150 to 30 degrees but referred to this quadrant. This function is positive. Now let's do another example. In the very same quadrant, let's say the cos. In the very same quadrant, let's say the cos of 150 degrees. So we are reducing. Now we're going to use this angle in this quadrant. Now this is negative. Now it won't be positive because the cos of an angle is negative in there. It's not positive. Negative the cos of what? Of that acute angle. So we are reducing bigger angles to acute angles. Here is another example. From the actual positive x-axis all around, let's say this angle is 240 degrees. 0 degrees, 90, 180, 270, 360 when we rotate the arm. Right, now when we join from the end of the arm, we always join in connection with the x-axis to form a right angle triangle. Right, now the reduction formula again. Now we're going to use a function. Now this angle in here, the angle inside this triangle, let's say it is theta. Now what is the size of theta? Now 240 all around to the arm. But now 180 is completed in line with this x-axis. Then now we're going to add a value. What is that value? That value is 60. Now theta is 60. Now when we refer to this quadrant, for example, again, sine of 240 degrees is equal to, is the sine of an angle positive in here or negative? All students take chances. Now the sine of an angle is not positive there. It means it's negative, but it's gonna take this acute angle 60. So when you press this on your calculator again to check, you're going to get the very same answer. We reduced 240 to what? To 60 degrees by the reference angle when we refer to this quadrant. So the reference angle is a positive acute angle in a right angle triangle referred to a quadrant. Right. For example, the sine, let's check if this is correct. The sine of 40 degrees is equal to negative the square root of 3 over 2. Let's check if it is the same as negative the sine of 60. Negative the sine of 60 degrees is equal to. It is the same. Now, that's how we reduce these angles. I can do another example. Let's use the cos. The cos of 240 degrees is equal to, in this quadrant, when we use this reference angle, remember the reference angle is 60. Now, is cos of an angle in this quadrant positive or negative? Is negative. Then it's minus the cos of 60 degrees. Now, when you press this on your calculator again, you're going to get this the same. Now, you can check again with the tangent. The tangent of 240 degrees in that quadrant. Now we're going to use an acute angle, reference angle referred to this quadrant in that right angle triangle. Now this angle is 60. So is that function positive or negative? It is positive. Positive, the tangent of what? Of this reference angle, 60. So when you press this on your calculator, you're going to get the same answer. The tangent of 240 is equal to the square root of 3. Let's check if it is the same as the tangent of 60. Now the tangent of 60 degrees. We get the same answer. That's how we reduce angles to acute angles, but referred to the quadrant. Right, I can do another example again in the fourth quadrant. Right, the example in the fourth quadrant. Let's say all around from the actual positive axis to the arm. Let's say the angle is 330 degrees. Right. From the end of the arm, we draw a vertical line joining the x-axis, perpendicular to the x-axis. Now, this is our reference angle inside that triangle. Now, what is the size of that reference angle? Now, 330 all around to the arm. Now, we're missing an angle here to complete 360. The size of that angle is 30 degrees. Right, now, now we can determine the cos of 330 degrees. We're going to reduce this angle, refer to this quadrant, so that this angle is now an acute angle. Now, this is the same as positive. Remember, cos of an angle is positive in here. Cos of what? Of 30 degrees. When you press your calculator, you're going to get the same answer. Right. Another example, the tangent of 330 is the same as negative the tangent of what? Of 30 degrees. So now this is 360 in this quadrant, and now that we want to use an acute angle, now because the arm is in this quadrant, then we're going to give tangent negative, because tangent is not negative, it's not positive in here, it is negative. Right. The general reduction formula is determined as follows. Right, when we measure by rotation of the arm, if the arm is in this is in the second quadrant, we actually completed 90, but we didn't complete 180. Then the reduction formula is 180 minus a reference angle. If the arm is in here, we're going to complete 180 and subtract any acute angle, not more than 90. Then the arm will always be in here. This is a reference angle, theta. 180 minus reference angle. Now, in the second quadrant, again, from the positive x-axis all around, we complete 180 now. Now, the arm is in here. Right. Now, we exceeded 180, but we added an acute angle. This is theta. That's why we always join the x-axis. Then this is the direction formula in this quadrant is 180 plus theta. Now, in the fourth quadrant, now, all around, we completed 270 and then right to the arm, then we didn't complete 360. This is 360. Remember, we want to use this angle, this reference angle. When you join a right angle triangle, you're going to see why we are using 360, not 270. Right, 360 completed, then we subtract, we take back the arm, we subtract theta. This is 360 minus reference angle theta. You can go further in the first quadrant. 360 is completed, and then we add theta. This is the first quadrant. So this is the complete reduction formula. I'm going to explain the reduction formula that leads us to cofunctions after learning about this simple reduction formula. So from this simple reduction formula, let's say we are given the sine of 180 minus theta. Remember, 180 minus theta is an angle that is more than 90. Now, we would like to reduce it and give this function this acute angle. Right now, by looking at this reduction formula, we know where this arm is. It is in the second quadrant. Now, we would like to give this function an acute angle. Now, we're going to check. Oh, in the second quadrant, this function is positive. Then this is positive, the sine of theta. The same as what I did. Remember, we set the sine of 150 degrees is the same as, remember, 150 is what? Let's check. Is 180 minus 30 degrees. By reduction, 150 is 180 minus 30 degrees. Now, I would like to give this an acute reference angle. Then this is positive. Remember, this 150 is in the second quadrant. Then now, this is positive, the sine of 30 degrees. So when you press on your calculator, you're going to get the same answer for this. Now again, let's say we have the cos of 180 plus theta. Now, in which quadrant is 180 plus reference angle plus theta? In the fourth quadrant. Now we're going to think about this function. Is this function positive or negative? No, it is not positive, it is negative. Negative, the cos of an acute angle. I can make an example with the size of the whole angle 180 plus cos of 215 degrees. Let's say 215 degrees. Now we're going to use the knowledge of the reduction formula and check what is added to 180 to get this 215 degrees. Right. Now, we added 35 degrees. Now, this is 180 plus 35 degrees. So now, when you use this knowledge of reduction formula, we would like to give, remember, this is a reference angle, 180 plus. Then this is the same as minus the cos of 35 degrees. That is introduction to reduction formula and understanding of reduction formula and what it means. So now we're going to answer more questions about this.